Hello everyone, myself Shan Sharkar from second year EC department at Coachware Government Engineering College. So today I will present you a brief introduction video of analog communication. This presentation provides an overview of analog communication systems. We will explore the key elements and their functions and also discuss the concept of modulation and its practical needs. So let's start. There are four elements of a communication systems. First of all, source. Source is the origin of the information, such as voice or music. Next, transmitter, transmission channel, and at last the receiver. So let's move to transmitter. So the transmitter plays a crucial role in processing signals, converting raw data into a format which is suitable for transmission. Uh, and next, oscillator. Oscillator generates the carrier signal, which is a stable and consistent waveform at a specific frequency. Modulator. It imprints data onto the carrier signal by varying its amplitude, frequency, or phase in accordance with the message signal. Amplifier. It amplifies the modulated signal to increase its power, ensuring that it can travel far enough to reach the receiver without being overwhelmed by noise or any interference. So let's move to the transmission channels. It is the medium of the system. Coaxial cable has high bandwidth and low noise for wired connections. Fiber optic cable has very high bandwidth and immune to interference. Next, radio waves have long range for wireless communication. Satellite communication has global coverage and it is achieved with high latency. Next, move to the receiver. Uh, Amplifier. Amplifier boosts weak received signal, increasing its amplitude for further processing. This ensures that the signal is strong enough to be properly demodulated and interpreted. Filter removes unwanted noise and interference from the amplified signal, improving the signal to noise ratio. This enhances the clarity of the received message by eliminating spurious signals. Demodulator extracts the original information signal from the modulated carrier wave. This process reverses the modulation performed at the transmitter, recovering the intended message. So now the concept of modulation. So what is modulation? Modulation adds a message to a carrier signal by changing its size, speed, or angle. Frequency moves the message signal to a higher frequency for better wireless transmission. Sends many signals at once on one channel, saving bandwidth. It allows smaller antennas to send signals effectively, since antenna size depends on signal frequency. Needs of modulation and its practical use, like antenna size. Modulation lets smaller antennas be used. Interference signals are separate in the frequency domain. Range. Higher frequencies travel further. Types of analog modulation. It's majorly in three parts. First, AM. AM is amplitude modulation, which varies the carrier signal's amplitude, simple but prone to noise. Next, FM, frequency modulation, which varies the carrier signal's frequency, less noise, more bandwidth needed. At last, PM, phase modulation. It varies the carrier signal's phase, efficient with good noise performance. So, summary and the conclusion. So we cover the basics of communication, why modulation is important and different ways to modulate signals, how it is used. You will find it in radio, TV, satellite, and older cell phones. So communication systems are getting better with new ways to modulate signals, process them, and use antennas. Analog communication is still important. It is the base for radio, TV, and other systems. The future will bring better ways to modulate signal, process them, and design antennas. So thank you. That's it for today. Thank you for your time and attention. I hope you find this presentation informative. So that's it from my side.